Assalamu alaikum, all viewers and dear students. Today we will discuss about the sum limits and important rules. We are trying to prove it. We start from the limits of limits x tends to a, x minus a, x under root minus a under root is equal to 2 under root a. Taking left hand side, taking left hand side, limit x tends to a, x minus a divided by x under root minus a under root. We apply limits on the both numerator and denominator. Limit x tends to a, x minus limit x tends to a divided by limit x tends to x under root minus limit x tends to a under root. Now, in the place of x, we put the limit directly. We put x is equal to a, so we get the result a. And here is we use the constant rule, because according to the constant rule, if the x value is not present here, x is not present, so we put directly x is equal to a. Similarly, here we put x is equal to a under root minus, and here we put, here is also the constant rule, limit x tends to a, here x is not present, so we put directly a under root. Both are cancelled to each other, so we put 0 divided by 0, 1. So this case is undefined. Now we are proceeding to some methods. First, we check factorization whether it is possible or not. If it is not possible, then we are proceeding to the rationalization method, or we can say that we apply the conjugate of the denominator term. So now we are using the rationalization method. Limit x tends to a, x minus a divided by x under root minus a under root. We are apply here the conjugate of x under root plus a under root divided by x under root plus a under root. It is also called rationalized. Now we are applying the limits according to, we get here the formula a minus b, and to here is a plus, here is b, a plus b. A minus b into a plus b, we get a square minus b square. Now we apply on the denominator terms, we apply this formula. Limit x tends to a, x minus a into x under root plus a under root divided by a square minus b square. We put the value of a is equal to x under root and b is equal to a under root, and here we use the formula a square minus b square. Now limit x tends to a, x minus a into, we can write x under root plus a under root divided by, here we can square root is equal to x 1 by 2. So square minus a 1 by 2 square root is equal to 1 by 2. So this term both are cancelled to each other. So we can write limit x tends to a, x minus a into x under root plus a under root divided by x minus a. Both are cancelled to each other. So the remaining term is limit x tends to a, x under root plus, we can also apply limit x tends to a under root. Now here we put in the place of x is equal to a under root plus and here is constant rule is available, so we directly a under root we put. Now we get the coefficients of the both terms. So here is the coefficient is 1 and here is 1. We add 2 under root a, which is the required result of left hand side. So we can say that limit of x tends to a x minus a divided by x under root minus a under root is equal to 2 under root a. So we can say that that is right hand side, right hand side, left hand side is equal to right hand side, which is the required proof. Is x, so the result will be equal to e. Now taking left hand side, taking left hand side is equal to limit x tends to infinity 1 plus 1 over x whole power x. Now if we directly put the limit, so the result is not giving e. It means that we consider this term, consider the term 1 plus 1 over x whole power x. Now look here, 1 plus 1 over x whole power x. This is according to the binomial theorem. Here we use according to the binomial theorem. Now here we have binomial theorem, binomial expansion 1 plus x whole power n is equal to 1 plus nx plus n into n minus 1 divided by 2 factorial x square plus n into n minus 1 n minus 2 divided by 3 factorial x cube up to so on. According to this binomial expansion, we expand this term 1 plus 1 over x whole power n. It means that if we compare both terms, here 1 is equal to 1 and x is equal to 1 by x and n is equal to here, here is x, here is x and n is equal to x. Now expanding by this formula, now 1 plus n, in replace of n we put x, and in replace of x we put 1 over x plus n. In replace of n we put x into x minus 1 divided by 2 factorial x square. In replace of x we put 1 over x whole square. Similarly, x into x minus 1, x minus 2 divided by 3 factorial. In the place of x, we put 1 over x whole cube up to so on. Now we simplify this term. Look here, x and x are cancelled. We get 1 plus 1 plus here if we take from the first pair, we take common x. So we write 1 divided by 1 over x divided by 2 factorial, expand 1 square 1 and x square we can write plus similarly here is common, x is common from the first pair, x we can write x1 minus 1 by x. Similarly here x is common from the x minus 2, so we write 1 minus 2 by x divided by 3 factorial and 1 expand cube times, so we 3 times, so we get 1. Similarly 1 over x 1 cube up to so on. Now 1 plus 1 we get 2, 2 plus x multiplied by x, x square into 1 minus 1 by x divided by 2 factorial 1 divided by x square plus x multiplied by x multiplied by 3 times multiply, so we add the exponent. Here exponent is 1, 1, 1, we add all these 3 terms, we take the base 1 1 plus 1 plus 1, 3 times we get x power cube into 1 minus 1 by x into 1 minus 2 by x. And here we can write 3 factorial, we can write 6 because 3 factorial we have 3 factorial we can write 3, 2 and 2 1. So we will get 6 and 1 cube 1 divided by x cube plus up to so on. So x cube and x cube are cancelled, x square and x square are cancelled. So we get the answer 2 plus 1 minus 1 by x divided by 2 plus 1 minus 1 by x and 2 1 minus 2 by x divided by 6 plus up to so on. Now here limit is required, limit extends to a on both sides of the term v. So the result is 1 plus 1 by x whole power x. Now we applying limit extends to infinity on both sides of the equation. So we will get here limit extends to infinity 1 plus 1 by x whole power x is equal to limit extends to infinity 2 plus 1 divided by 1 minus x divided by 2 plus 1 divided by 1 minus x into 1 minus 2 divided by x divided by 6 plus up to so on. Now look here, here is constant is available, so we apply limit extends to infinity 2 plus limit extends to infinity 1 minus 1 by x divided by 2 plus limit extends to infinity 1 minus 1 by x 1 minus 2 by x divided by 6 plus up to so on. Here constant rule we can apply, so we get constant, and here 1 minus 1 divided by infinity divided by 2 plus 1 minus 1 divided by infinity 1 minus 2 divided by infinity divided by 6 plus up to so on. This is the rule, one of the rule. We can 1 divided by infinity we get 0, 2 divided by infinity we get 0, so up to so on, n divided by infinity is equal to 0. Something in the denominator infinity term is coming, so we will get answer 0. Now we will get here 2 plus 1 minus 0 divided by 2 plus 1 minus 0, 1 minus 0 divided by 6 plus up to so on. And we get here 2 plus 1 by 2 plus 1 by 6 up to so on. So if we add, we get 2.7183. This is the value of E, which is right hand side. Now taking left hand side, taking left hand side, limit extends to 0, a power x minus 1 divided by x. If we apply the limit extends to 0, a power x minus limit extends to 0, 1 divided by limit extends to 0 x. So here if we put a power 0 minus 1 and here we put 0. So 1 minus 1 anything raised to the power 0 we will get 1. So we get 0 divided by 0 form. This is undefined case. So we are using some substitution method, factorization method, rationalization method. Now we put here we put a power x minus is equal to y. Now ax is equal to 1 plus y. We change this value, so minus 1 is positive. Now taking log on both sides, apply log on both sides of the equation. So according to the logarithm rule, m power n exponent rule, we change n here to the coefficient log of m. According to this rule, we apply on the both terms x log of a is equal to log of 1 plus 1 over y. Here x is equal to log of 1 plus y divided by log of a. Log of a. When now we check the limits, when x tends to 0, then what is the value of y? A 0 minus 1 is equal to y. So 1 minus 1 is equal to y, 0 is equal to y. That means that y tends to also approaches to 0. Now we substitute, apply the values of limit y tends to 0. In the place of ax minus 1 we put y, and divided by, in the place of x we put these two results, log of 1 plus y and log of a. Now here we can also, this value will change. Limit of y tends to 0, we change double division, so y log of a divided by log of 1 plus 1 over y. We change this value to denominator according to the double division. Now limit y tends to 0, log of a divided by, we can write this value, this term 1 over y, and log of 1 plus y, because here y is available, we change this term 1 over y, so, and double here reciprocal, we take the reciprocal of this value, so once again we change this value. Now apply the, according to the power rule, we change this value, limit y tends to 0, log of a divided by, we change this rules, log of 1 plus 1 over y whole power 1 over y according to the exponent rule. Now, so this result will be equal to log of e. This value is equal to log of e, limit y tends to 0, log of a divided by log of e. As we know that log of e is equal to 1. So if we are applying limit, so the result is limit y tends to 0, limit y tends to 0, log of a divided by 1. So here is constant, there is no y is present, it means that log of a is the result, so which is right hand side. So we can say that limit of x tends to a power x minus 1 divided by x is equal to log of a, where a is greater than 1. We can write this one, log of a is equal to a is greater than 1. Both results are. Now another important result, x plus a under root minus a under root divided by x minus a is equal to 1 by 2 under root a. We want to prove this result. Here is x plus a under root minus a under root, limit x tends to 0. Just like in the previous result, we have already done this one. Now taking left hand side, taking left hand side is equal to limit x tends to 0, x plus a under root minus a under root divided by x. If we apply limits individually on each term, so limit x tends to 0, x plus a under root minus limit x tends to 0, a under root divided by limit x tends to 0, x. Look here, we apply limit individually by each term, numerator and denominator. So we put in the place of x, we put 0, 0 plus a under root plus minus. Here is constant rule because x is not present. So this is the constant rule divided by, we put here 0. Now what is the result? 0 plus a under root, we get a under root minus a under root divided by 0. So result is both are cancelled. So result is 0 divided by 0 form, which is undefined. Now we are using factorization method, rationalization method, and any one substitution method you can use according to the question. Now here we are applying rationalization method. Limit x tends to 0, limit x tends to my x plus a under root minus a under root divided by x. We are using, now we take the conjugate of this term, x plus a under root plus a under root, and also we divide the same result multiplying and dividing by the conjugate of on denominator terms. We can also say that. Now look here we can use the formula a minus b, a plus b, we get a square minus b square. Limit x tends to 0, here x plus a under root a square minus a square under root square, and here denominator we multiply to each other plus a under root. So here both are cancelled to each other. Limit x tends to 0, we get the answer x plus a minus a divided by x into x plus a under root plus a under root. A are cancelled and x are also cancelled. So limit x tends to 0, we get 1 divided by x plus a under root plus a under root. Now we are applying limit on the numerators and the denominator. Limit x tends to 0, 1 divided by limit x tends to 0, x plus a under root plus limit x tends to 0, a under root. Now look here is again constant root because x is not present, so we put 1, and here x is equal to 0 plus a under root, and here is also constant root because x is not present, so we get the result a under root. Now simplify 0 plus a under root plus a under root, so we add the coefficient of the denominator. Here is 1 and here is 1, so 2 under root a, which is right hand side of the limits. So limit x tends to 0, x plus a under root minus a under root divided by x is equal to 1 by 2 under root a. Thank you very much for watching. Once again, this is very interesting. Now we, inshallah, in the next video, we are proceeding to the exercise. These are the some limits. So these are the rules if we are applying in the limits. Thanks once again for watching.